All right, here's our 10.2 notes. And again, you're going to need a highlighter, so go ahead and find one real quick right now if you do not have one. Okay, so we're talking some more about quadratic functions, and we're going to look specifically at some of the forms of equations that we can have. So when a quadratic equation is written in the form y equals ax squared plus bx plus c, we call that standard form. Now we're familiar with that from last semester. What we talked about last semester is that in order for our answer to be written in standard form, we had to have highest power to lowest power. So same idea here. We've got standard form, highest power to lowest power, x squared plus bx plus c, and we can have the a value in front sometimes. Okay, so to find the vertex, when we have an equation that's in standard form, we find the x value of our vertex by using this little equation here, and it's kind of jammed there, so I'm going to rewrite it here. X equals negative b over 2a. So when we have that b value in the middle, when we have a bx term, we're going to use x equals negative b over 2a. We put whatever the b value is, divided by, we make it negative, or change the positivity, and then we divide it by 2 times whatever our a value is. And that gives us the x coordinate of our vertex. Then once we have that, we just substitute that, plug it back into our equation to find the y coordinate of our vertex. And then a reminder here, the x coordinate of our vertex is on our line of symmetry. So our LOS, or our line of symmetry, our axis of symmetry, is always equal to the x coordinate of our vertex. LOS standing for line of symmetry. Vertex. Okay, so we're going to look at some of these examples, find the equation for our axis of symmetry and the coordinates for the vertex of our graph. Okay, so without graphing, we can look at this equation. We can use our x equals negative b over 2a to give us our x coordinate of our vertex. So our b term here is this 6, so we're going to identify that our x is going to be equal to negative 6 over, and then our a term is this 3, so we're going to have over 2 times 3, negative b over 2a. Then we evaluate that, that is negative 6 over 6, or just negative 1. So for our vertex, we know that the x coordinate is going to be negative 1, and we have to find our y coordinate. Whenever we have a function and we know what the x value is, we can just plug that x value into our function to find our y value. So we're going to take this x value, plug it in. So we're going to have y equals, I'll write this a little bit over here, y equals, I'm going to have 3 times negative 1 squared plus 6 times negative 1 plus 2. And I would encourage you guys, whenever you are substituting, to always put it inside of parentheses. Okay. So now we're going to evaluate this. Y equals 3 times negative 1 squared would be 1. 6 times negative 1 would be negative 6, so that's going to become a minus 6, and then I have a plus 2. That is 3 minus 6 plus 2. And when we are doing order of operations, we must go left to right for addition and subtraction. So 3 minus 6 is negative 3. And then we add 2, we get that the y value is negative 1. Okay, so our vertex is at negative 1, negative 1. That's our vertex, and then our line of symmetry, or our axis of symmetry, line of symmetry, axis of symmetry, you'll see it both ways, is going to be x equals whatever our x coordinate there was, negative 1. So here's our line of symmetry, and here's our vertex. The two things that they asked us to find, right? Okay, so that's example 1. Example 2, same process. To find the x coordinate of our graph, we're going to do negative b over 2a. So our b term here is negative 8. We're going to have x equals negative b. B is negative 8, so we have to go negative, negative, over 2 times a. Our a term here is negative 2. So we're going to have 2 times negative 2. Negative negative 8 would be positive 8, over 2 times negative 2 would be negative 4, that gives us an x-coordinate of -2. So for our vertex, we have an x-coordinate of -2, and then we need to find our y-coordinate. And again, whenever we have an x value and a function, we can just plug the x value into our function to find the y value. So we have y equals -2, and again, I'm going to encourage you to always put it in parentheses. -2 times x squared minus 8 times x minus 3. That is y equals -2 times 4 plus 16 minus 3. That is y equals -8 plus 16 minus 3. And again, left to right. -8 plus 16 would be +8. Minus 3 would be 5. So our y-coordinate for our vertex is 5. Here's our vertex. And then our axis of symmetry is going to be x equals -2. Because that is our x-coordinate there. All right. So pretty easy process once you get the hang of it. You will want to make sure that you remember this -b/2a equation. So I'll do one more, and then I would like you guys to do the last one. So this problem, just like the other ones, but instead of y, we have f of x. We identified yesterday that this is called function notation. F of x and y are interchangeable. Notation. F of x is the same as y. Whoa. They're interchangeable. Okay. F of x is kind of like better vocab. So you think like at some point we use cool to describe something good, and then, sorry, excuse me, I had to sneeze. You know, at some point in our life we use cool when we like something, you know, and then we get better vocab to describe it, like something is awesome, or it's splendid, or we really appreciate it. So f of x is like better vocab. It's better math vocab. Okay, so we're going to use our same thing to find our vertex. We're going to x equals -b/2a. So we have our b term is 2. So -b would be -2 over 2 times a. Well, a here, there's no number in front of x, so that means there's a 1 there. So that's 2 times 1. So we evaluate it. -2 over 2 is -1. So our x-coordinate of our vertex is -1. We got to find our y-coordinate. We're going to plug it into our function. So plugging it into our function, when we have f of x, looks like this. F of -1 equals -1 squared plus 2 times -1 minus 3. And then we evaluate it just like normal. This f of -1 represents the y value when x is equal to -1. 2 times -1 would be -2 minus 3. Left to right, 1 minus 2 is -1, minus 3 is -4. So the function when x is equal to -1, the function is equal to -4. There's our vertex, and then our axis of symmetry, the equation for that would be x equals -1. All right, that is example 3, and I would like you guys to do example 4 here on your own. So do this one on your own, see if you can identify what the vertex is and the line of symmetry, axis of symmetry. Okay. So coming down here, when we substitute x equals 0 into the equation, we get, so if we substitute x equals 0 here, then a times 0 squared would be just 0, right? Plus b times 0 would be just 0. So we end up with just y equals c, because the a and b terms both cancel out. That is the y-intercept. So if we substitute, we know that a y-intercept always has an x value of 0. Okay? 0, whatever the y-intercept is. So the y-intercept of a quadratic function is always whatever that constant term is. C is our constant, meaning that it is not, it doesn't have a variable. Right? So write that here. Constant means that it doesn't have a variable. Write that, and again, I'll see who listened by who wrote that. Constant means you don't have a variable, number without a variable. So find the y-intercept of the following functions. It's simply whatever this constant is. So the y-intercept of this function, x is always 0 for our y-intercept, and the y-intercept would be -3 because that is our c value here. Y-intercept here, x will always be 0 for our y-intercept, and our constant term in this expression, or in this equation, is -7. So identifying the y-intercept from standard form is very easy. And we can pretty easily find the vertex by using that little -b/2a. So those are two things that we can identify fairly quickly when a quadratic function is written in standard form. So we talked about the average rate of change pattern with quadratics. It is always increasing odds, 1, 3, 5, 7, unless you have a value for a. And then in that case, it would be 1 times whatever that a is, 3 times whatever that a is, 5 times whatever that a is, etc. So we're going to use that, and also knowing that a parabola is symmetric, and then using the vertex and y-intercept that we can find from standard form, we're going to use that all to graph these functions. So we're going to identify first what the vertex is, using, this is in standard form, so we're going to use our -b/2a. Okay, x equals -b/2a. B here is +4. So I'm going to have -4/2 times a. My a again is 1. -4/2 is -2. So that is the x coordinate of my vertex already set up here. And then I'm going to plug that in to find the y coordinate of my vertex. So y equals -2 squared, x squared, plus 4 times x plus 4. That is 4 minus 8 plus 4. 4 minus 8 is -4 plus 4 would be 0. So we have our vertex at -2, 0. So I'm going to put that on my graph. -2, 0 is the vertex of my parabola. So I know that this is either going to be the minimum value and my graph's going to go up, or it's going to be the maximum value, my graph's going to go down. As I look at my a value, it is positive, so this graph is going to face up. So I know that it's going to look something like this. I'm going to sketch it on there. Don't sketch it on there. I'm just sketching it on there, okay? I know it'll look something like that. I know that my line of symmetry is going to be the x coordinate of my vertex, and I know that the line of symmetry goes right down the middle of my parabola. So my line of symmetry, if I folded my parabola in half over that line, it would match up exactly. Okay, because my graph is facing up, I have a minimum. That's the lowest point that my graph will have. Clean this up a little bit. Line of symmetry. Clean that up. Oops. Okay, my y-intercept. So my y-intercept, again, because this is in standard form, is simply 0, comma, whatever that constant number is. So back to my graphing, I can put my y-intercept on my graph. I know it goes on the y-axis. And my y-intercept is 4, so I know I'm going to have a point at 0, 1, 2, 3, 4. And I know that that will be symmetrical on the other side of this line of symmetry, so I can just take this point and reflect it over this line. I know that my parabola will go through both of those points. So I can now sketch my parabola just from those points, and it's going to go up through there and be symmetrical on both sides of that line of symmetry. My domain, again, 90.9 or more percent of the time is going to be all rails. And then my range here, because my graph is going up, my range, the y values are greater than or equal to whatever the y value of this vertex is, which is 0. So the y value of the vertex determines where your range is restricted. Okay, so a lot of different characteristics of the graph that we can identify from that standard form, and we can graph it using our knowledge of the symmetry of the graph. Okay, last example here. I'm going to identify my vertex. Equation is in standard form, so x equals -b/2a will give me the x coordinate of my vertex. -b/2 times a is -12/2 times -6, or -12/-12, which is 1. The x-coordinate of my vertex is 1. To find the y-coordinate, I plug that x-coordinate into my equation. Negative 6 times 1 squared plus 12 times 1 minus 3. That is negative 6 plus 12 minus 3, which is 6 minus 3, or just 3. So my vertex is at 1, 1, 2, 3. There's my vertex. Okay, now I'm looking at my a value here. It is negative, so I know that my graph is going to face down. I know that my line of symmetry, so because it's facing down, I know I'll have a maximum. My curve is going to go down because a is negative. My line of symmetry is going to be at x equals 1, the x-coordinate of my vertex. My y-intercept is going to be 0, whatever my constant is, 0, negative 3. So I can put that y-intercept on my graph here, 0, negative 3. I can see that's a pretty steep graph there. I know that my line of symmetry is right here on my vertex. So I can take this point and reflect it over that line of symmetry, and I know that my parabola is going to go down through both of these points, like such. My domain, again, is all reals. There's no restrictions on my x values, and my range is going to be y is less than or equal to whatever the y-coordinate of that vertex is. Less than or equal to because my graph is going down. So one thing to take note of, and we'll talk about it more and more as we continue to graph, but the greater the a value is, then the narrower the graph. So we see this, the greater the absolute value of the a is. So this a is negative 6, absolute value of that would be 6. Absolute value of this a value would be 1. So the 6a has a more narrow graph than the 1. And again, we're going to continue to talk about that, so it's okay if that didn't make a whole lot of sense yet. We'll see it more and more. All right, make sure you write down any questions or shoot me a reminder or email. And I'll see you tomorrow.